Welcome to solverfy.
Okay, so the Gale-Shapley algorithm pairs these suitors and suitees, and there should be an even number of each in order for there to be pairs at the end, right? So you would have both n suitors, which we'll just let be x, and n suitees, or the ones being proposed to, right? And so it can be, oftentimes these are written in a romantic setting of partners, but it can be a college and students that it's accepting. Anyone where there's a proposal and an acceptance involved. Okay, so we know that there are both n suitors and n suitees. So for proof of contradiction, let's assume that the algorithm terminated. So the GS algorithm has terminated. Leaving some x unpaired. Okay. Well, then that means that there is some y, some suitee, that is also unpaired. Because this algorithm doesn't allow for like triplicates to join up, only pairs. And since there's n of x and n of y, if one x is unpaired, then one y must be unpaired. Okay, but if it's good to observe that if y gets at least a minimum of one proposal, then they get paired. Right? So initially, if there's no pairing, the pairing occurs, and then from there on, you never become unpaired. You just sort of trade up. Okay, but so in order for there to be an unpaired y at the end, then that would imply that this particular unpaired y was never proposed to. But in order for the algorithm to terminate, right? Because this algorithm goes through every iteration of these preference lists, right? So in order for the algorithm to have terminated, just by the way the algorithm is defined, there must have been a proposal. So this is a contradiction. Okay. Because in order for termination, this particular x would have been rejected by y. But since y is unpaired, that's not possible. All right, so therefore, x must be paired at termination. Okay, and then that is the end of this proof by contradiction.